Hello everybody and welcome to my video on implicit differentiation. First we're going to talk about the differences between implicit and explicit functions and differentiations. Then we go through some examples and at the end I give you a shortcut to get this solution a bit faster. So up to now, whatever we have worked with have been just implicit functions, where y is defined, explicit functions, where y is defined explicitly as a function of x. Let's say x cubed plus root x plus 1. Here you just give a value to x as the input, and the output or the value for y just pops up. It's not hard at all. Sometimes it is hard or impossible to solve for y in terms of x. And that's when we say y is defined as a function of x in an implicit manner. The simple example is x squared plus y squared equal to 1, which just so you know is the equation of a circle with radius 1 centered at the origin. And if you just look at the graph, you notice that y here is not a function of x, and for any value of x in the domain you get two values for y, but still we can solve this for y. Subtract x squared from both sides and take a square root, keeping in mind that we get two solutions, so plus minus root 1 minus x squared, and now you can differentiate y with respect to x explicitly as we have done before. But like I said, sometimes it is impossible to solve for y in terms of x analytically, and if you want the analytical expression for the derivative, you have to use implicit differentiation. This is a simple example. We can find the derivative easier. So the derivative here at any point x and y located on the circle is just the slope of the tangent line. And just so you know, the tangent line is perpendicular to the radius from geometry. If we take this angle as theta, and you remember from trigonometry that tan theta, or the slope of this line, is y over x. And if you remember, two perpendicular lines have negative reciprocal slopes. So the slope of the tangent line to the circle at point x and y must be negative reciprocal of y over x, so negative x over y. Let's get the derivative not using geometry. So what does this expression mean? It means x squared plus y squared is always 1. So no matter where on the circle you are, sum of x squared and y squared must not change. So if you, for example, move from x and y to neighboring point, x plus dx and y plus dy, sum of the squares of the first and second coordinates should not change. So here I get x squared plus y squared, and on the right I get x plus dx squared plus y plus dy squared. If I expand the right hand side, get x squared plus 2x dx plus dx squared, and similar things for y squared 2y dy plus dy squared. X squared and y squared cancel from both sides. And if you remember, dx is infinitesimal change in x. It's really small. When you square it, it gets even smaller. So dx squared compared to 2x dx or dy squared compared to 2y dy is actually negligible. So we get 0 on this side, And this on the right we have 2x dx plus 2y dy. And if you solve this for dy dx, you get negative sign. Dx should be multiplied by 2x and dy multiplied by 2y, so negative x over y. So things match and math is not broken. But how do we do it in general for more complicated functions? You know how to do it here. You just apply d dx to both sides of the equation. I mean, to talk a bit more technically, here you do the same. So d dx of x squared, and you can separate the derivatives, obviously, and d dx of 1 is just 0. Derivative of x squared with respect to x is just 2x. And here we have to use chain rule. So if I have a function g in terms of y, let's say here is y squared, and I want to find dg dx, we did dg dy times dy dx from chain rule, which is nothing other than just multiplying and dividing by dy, and it's a legit thing to do because dy is not 0. So d of y squared with respect to x is d of y squared with respect to y times dy dx over y prime. D of y squared with respect to y is 2y, times dy dx. So we get 2x plus 2y dy equal to 0, which is same as this equation we got here. Now let's go to a more complicated function and apply this concept to it. Let's see how it goes. Okay, let's do sine of y times cos of x squared is equal to e to the y. As far as I can think of, it's, for me at least at this moment, it's impossible to get y in terms of x analytic. So what was our technique? Applying d dx to both sides and keeping in mind that y is a function of x. So what happened really in here? When you have the derivative of a function in terms of y, so you just differentiate it normally. Derivative of y squared with respect to y is just 2y, and then you include dy dx in front of it. Wherever you're doing this technique on a function of y, that's the same procedure. Differentiate normally with respect to y, and then include dy dx at the end. Here we have the product of two functions, so we're going to use product rule. Derivative of sine y, so d dx sine y times cos x squared plus derivative of cos x squared times sine y is equal to the derivative of e to the y. So here we are differentiating sine y with respect to x. So I differentiate sine y with respect to y first, which is cos y, and then include dy dx times cos x squared. Here cos x squared is just function of x, so you do your normal differentiation, which is the derivative of the inner function times derivative of cos, which is negative sign, where its argument is replaced by this inner function. times sine y. And on the right, you differentiate e to the y with respect to y, which is e to the y times dy dx. As you see, we have two terms involving dy dx. So we have to bring all the terms with dy dx to one side and solve for it. So I move this term to the right, the negative becomes a positive, so I get 2x sine x squared sine y. And here I get dy dx. So I kept this on this side, move this to the right, and I move this to the left. I get cos y cos x squared minus e to the y. And then obviously you divide both sides by the coefficient of dy dx. Cos y cos x squared minus e to the y. So now is the time for the shortcut. On time, eh? Okay. The advantage of the shortcut is that you don't have to solve for dy dx. Gives you dy prime right away. But there's a payoff. You have to take care of another thing. But all in all, finding the solution is easier. The first thing you have to keep in mind for using this technique is bringing everything to one side. And it doesn't matter which side. So you can bring e to the y for this example to the left. And on the other side, you must have the 0 or any constant, doesn't matter. So we get a function mix up x and y, linked together. And on the right, I get a constant, or 0. Because the derivative of the constant is 0, it doesn't matter really. And the final formula for y prime or dy dx, I don't want to go through the derivation, it's still early. We get negative f prime sub x over f prime sub y. And what do these two mean? F prime of x means differentiate the IFF with respect to x, and wherever you have y, you are assuming it's a constant. And similar thing for y, obviously f prime sub y, you differentiate with respect to y, assuming x is constant. So let's work on that example and see if we get the same answer, which we must, and just compare the two. So first thing is bring everything to one side, get sine y cos x squared minus e to the y is 0. So we get first f prime sub x, differentiate with respect to x, y is constant. Y is constant, so sine of y is a constant. And we're just differentiating cos of x squared and multiplied by sine of y, which is assumed to be a constant. The derivative of cos of x squared is negative 2x sine of x squared. Same thing we got there. Times sine y. We are assuming y is constant, so the derivative of e to the y, which is also a constant, is 0. Now we get f prime sub y. So here, x and any function of x, or cos of x squared here, is just a constant, and you just differentiate sine y with respect to y. You get cos y times cos x squared. Minus, and derivative of e to the y with respect to y is just e to the y. And then we just sub in this formula of dy dx or y prime, and I apply this negative to this negative here, so they cancel. We get positive 2x sine x squared sine y over cos y cos x squared minus e to the y. Magic, we got the same answer. Okay, I believe that's enough for today. Later on we go to more advanced topics. And see you next time. Thank you.